Alright, so the second and the last example, so which is going to be for the subtopic and for the whole course as well. So I'm going to consider the function f of t is equal 3 plus t from -3 to 0. And we're going to sketch the function f of t and the waveform, the periodic function on interval from -9 to 9. And then we're going to write the analytical description of f star t. And after that, we're going to find the half-range Fourier cosine series. So now let's start with a first, so the sketching. So later I'm going to have to prepare this from -9 until 9. So I don't want to put 1 to 3 from -9 to 9. No, that's not going to happen. I'm going to use a scale of 3, 6, 9 on this side, and -3, so -6, and also -9 on this side. Okay, so as usual, so I'm going to pick the lowest and highest value and substitute right there. So what happens is that when t is equal to -3, I'll have a 0. So -3, 0 is going to be somewhere on the axis. And then when I substitute t equals 0, I'll have a 3. So 0, 3 is going to be somewhere up here. And all I have to do is connect these two dots because this is t to the power of 1. It's going to be a straight line. And of course I can check. So here my gradient value m is going to equal 1. And my intercept value is going to equal 3. So this is what happened over here. So my graph is going up and it is intercepting at the value of y equal 3. Or f star t equal 3. So it doesn't matter. Alright, so next what I'm going to do is, so we know that the periodic function is supposed to be for cosine series. And for cosine series, so we know that the function is supposed to be even. And when you wanted to find the other half of an even function, so you have to reflect it once on the vertical axis. And when I reflect this, and of course this is going to be the reflection, so this is how my line is going to look like. And I did mention this to you before, so the fact that this is going to be m equal 1, but when you have an even function, so the gradient is going to be the opposite. This is going to be m equal -1, but for this case, they share the same c value, which is going to equal 3. Now from there, I'm going to write the analytical description. So I can write that f star t is going to cover, so let me change that and put it at the top of here, f star t. So my f star t is going to cover from -3 until 0. So that's the first line. And the second line is going to be from 0 until 3. And it's been given in the question the fact that from -3 to 0, that is going to be 3 plus t. So here I'm going to have 3 plus t, and or t plus 3. So that will be the same. And for 0 until 3, so what differs is only the gradient. And the function will be 3 minus t, or -t plus 3. So both of them are the same. And you can either use either 3 minus t or -t plus 3. So whatever that suits you. Alright, so now here from -3 to 3, so that is going to be a distance of 6 units. So therefore, my period value is going to equal 6 units. So I'm going to have f star is going to equal f star of t plus 6. So that will be the analytical description. And of course, don't leave your graph like this, so fill it in. So it has to be filled in from -9 until 9. So I'm going to have another one cycle on the right hand side and another cycle on the left hand side as well. So that's how the graph looks like. My scale is not the same, so that's why it looks larger on the right hand side compared to the left. Okay, so now I'm going to start with the calculation. And for this case, what happened is that for C, so we are going to be calculating for cosine series. So your periodic function f star t is going to be an even function. So we know that for the case of even function, so bn is going to equal 0. So meaning by, so you have to do the calculation for two Fourier coefficients, which are going to be for a0 and also an. So now let's start with calculation for the a0. So my a0, this is going to be the formula, 2 over t, integral from d until d plus t, f of t dt. For this case, it's going to be f star t. So my t value is going to equal 6. My integral for this case is going to be from -3 until 3. So that's my lower and upper limit. So it's going to be from -3 to 3 of the function f star t dt. Okay, and here when I simplify this, because the case of we figured that f star t is going to be an even function because this is going to be cosine series, so we can change the limit. So here I'm going to have a 3. So when I change the limit, my new limit is going to be from 0 until 3. But when I multiply by 2, so I'll end up with 2 over 3 as the constant outside. And my function f star t, so from 0 until 3, so the function that we're supposed to use is going to be 3 minus t. So I'm going to have 3 minus t dt. So if you notice in the previous example, what happened is that the function is given, so that is the function that you use in your calculation. But for this one, so the function given is this one, but you in the calculation, you use the function that you come up with. So meaning by, if you come up with the wrong function, automatically your whole calculation is going to be wrong. So therefore, be careful with this. So you should know how to write the analytical description. So let me continue the calculation on the side. So I'm end up with 2 over 3. Okay, so now when I integrate 3, I'll end up with 3t minus, when I integrate t, it will be t squared over 2 and evaluate it from 0 until 3. So it's going to be the same idea as before. So now I'm going to substitute wherever there is t. I'm going to substitute the lower and also the upper limit. So I'll end up with 2 over 3. So 3 multiplied by 3, that's a 9 minus, so I'll end up with 9 over 2, that's 3 squared over 2. And then I'm going to have minus 0 and 0, so that will be the outcome. So this is going to be 2 over 3. So I'll end up with 18 minus 9. So 18 minus 9 is a 9. So I'm going to have 9 over 2. So which if I were to simplify, and I'll end up with a value of 3. So that is going to be the A0. Remember, I mentioned this in the previous example in the full range, the fact that A0 is always going to be a constant value. You should get a number for A0. And I'm going to proceed my calculation with the second Fourier coefficient, which is going to be an. But before I calculate an, remember you need the value of omega. For this case, omega is going to equal 2 pi over 6. So that is going to equal pi over 3 because it is in terms of a fraction. So that is going to change the level of difficulty of your calculation as well. So it's going to be a slightly more complicated. So this is going to be my formula for an. So I'm going to have f star t. This is going to be cos of n omega t dt. So I'll end up with 2 over 6. So my integral, so that is going to cover from -3 to 3 of the function f star t. And for this case, I'm going to have cos of n pi t over 3 dt, because here my value of omega is going to equal pi over 3. And as usual, before you start substituting the function f star t, so inspect the property first. So f star t is an even function, cos is also even. And when you multiply even and even, it's going to be even. So again, we can't change the limit. So here, I'm going to have 2 over 3, and my new limit is going to be from 0 under 3. And from 0 under 3, so the function f star t that we're going to use is the same as what we used for A0. So that is going to be 3 minus t. So it's going to be multiplied by cos of n pi t over 3 dt. So that will be the outcome. And I'm going to do the integration, but for this one, I'm going to need some space for the integration. So I'm going to differentiate 3 minus t, and I'm going to be integrating cos of n pi t over 3. So when I differentiate this, I'll end up with -1. And when I integrate this, cos is going to be sine. So I'll end up with something like this, sine of n pi t over 3 over n pi over 3. So do not leave it like this. So this is super complicated. If you substitute this into your calculation, change the form instead. So write this as 3 over n pi, flip it around, of the function sine n pi t over 3. So that will be the simpler form. And of course, when I differentiate -1, that will be a 0. And when I integrate this for the second time, so I'll end up with 9 over, so I don't need the bracket actually. So I'll end up with 9 over, now it's going to be n pi square. So sine is going to be negative cos. I'll end up with negative cos of n pi t over 3. So that will be the outcome when I integrate them. Alright, so all I have to do is put plus and minuses and we're done. So now I'm going to put it together now. So actually my integration, so I'll end up with 3 minus t being multiplied by 3 over n pi. So sine of n pi t over 3. And then I have negative, negative, and negative. So that will be a negative of 9 over n pi square. So cos of n pi t over 3. And this will be evaluated from 0 until 3. So now let's highlight all the places with the t that we're going to substitute. Okay, so what happened now is that when I substitute t equal 3 first, so into this equation, I'll end up with 3 minus 3. So that will be a 0 for the first term. And when I substitute 3 right there, I'll end up with 3 over 3. So that is going to be a 1. So I will have a minus of 9 over n pi square. So cos of n pi is going to be negative 1 to the power of n. And then I'm going to substitute t equals 0. Of course, when I substitute t equals 0, so the whole thing over here is going to be 0, and sine of 0 is going to be 0. And when I substitute right there, t is equal 0, I'll end up with cos of 0. But remember, cos of 0 is going to equal 9. And minus, I'll end up with a positive of 9 over n pi square. So that will be the outcome. Okay. So I'm not going to show you the long calculation. I think that I've shown you plenty of example already, and by now you should be able to tell that this will be the outcome of the calculation. And actually I forgotten my 2 over 3 at the front. Let me fix this. So this is going to be 2 over 3 over here, and this is 2 over 3 from our calculation. Okay, so now if I were to simplify this, I can actually write this as 2 over 3. And in here, I can write as, I can factorize the 9 over n pi square. And that is going to be multiplied by 1 minus negative 1 to the power of n. So that is how the calculation is going to look like. Let's use a different bracket for this. And I can actually simplify the 2 over 3 and the 9 as well. So this is basically going to be 1, and this is going to be 3. So I'll end up with 2 multiplied by 3. So that is going to be a 6. So basically this is going to be 6 over, so I'm going to have n pi square, so both of them square, of 1 minus negative 1 to the power of n. Okay, I know that for this case, I'm going to get differently for the case of even and odd. And so let me put 1 is going to be for n even, and 1 is going to be for n odd. So what happens is that if this is even, this is going to be 1. 1 minus 1, I'll get a 0. And when that is odd, I will get negative of 1. So 1 minus negative of 1. So I will get even. Okay, this is going to be odd. And 1 minus negative 1, that's going to be a 2. And I'll end up with a positive of 12 over n pi square. For the case of n, it is odd. And now I can put together my Fourier series. I can write that f star t is going to equal a half. So if I were not mistaken just now, what is my a naught? I think it's going to equal 3, isn't it? That's right, my a naught is equal 3. So a half of multiplied by 3 plus sum of n odd of 12 over n pi square. And this is going to be for the case of an. An is multiplied by cos of n pi t over 3. Okay, because that's my cos of n omega t. Alright, so now because this is going to be the case of odd, whenever that is n, I'm going to change that to 2n minus 1. So therefore here, my Fourier series, the end product is going to be 3 over 2. And plus a series from n, sorry, whatever that is, not related, I'm going to put that out first. Or you can actually pull it inside, that's fine as well, but I'm not familiar with that. I'm going to write this as 12 over pi square. So sum from n equal 1 to infinity. So here I'll end up with a cos of 2n minus 1 pi t over 3. And okay, so this is, let me put that at the back. Oh, it's because of the over 3. Okay, let me rewrite that. So now I'm going to cater with this one first, 1 over n square. I'm going to write this as 1 over 2n minus 1 square. So then only I'm going to write this part, which is going to be cos of 2n minus 1 pi t over 3. So it's going to be much easier if I were to write it this way. It's going to look neater than if I were to put it together. Okay, so that is going to be the outcome, and please bear in mind when you write this, so the bracket is here. So this is going to be cos of that whole thing right here. Over 3 is not cos over 3. It's actually the angle that is over 3. Okay, so that is going to be the end of this example over here, which marks the end of the cos as well. This is going to be the last video. I hope that you have benefit in some way of all the videos that I have produced for the syllabus, starting from Euler until this last subtopic of chapter 4 and the whole course as well. The video is going to be available for you until the final exam. Like some of you are going to do it earlier and some of you are going to do it in October, don't worry. So I'm not going to delete or anything. The video is going to remain there for you to use. Okay, so good luck for the final exam then.